All right, so little exponents review. Remember, when you multiply the same base on exponents, you add the powers, and when you have a power to a power, you multiply. Okay, we did that whole exponents review section, so hopefully you remember that. So, the last time we were here, we added and subtracted polynomials. Today, we're going to multiply them. Okay, so if you have a binomial times a trinomial, we're going to double distribute. We're going to take the 2m times all of them to get 6m cubed minus 4 and 8m squared plus 4m and then I'm going to take the 5 times each of them. So I'm going to get 15m squared minus 20m plus 10. Then if we add 6m cubed plus nothing is 6m cubed. Negative 8m squared plus 15m squared is plus 7m squared. 4m minus 20m is negative 16m plus 10. And that is our answer. Taking a binomial times a trinomial. We just have to be careful with powers. Uh-oh. Oh, there we go, finally. Okay, now we have 3 binomials multiplied times each other. So when this happens, I multiply my second 2 first. I FOIL these two. First, outer, inner, last. So I get m plus 1 times m squared plus 2m minus 8. Then I do just like that last problem. I take my binomial times my trinomial. So I take my first m times all these. So I get m cubed plus 2m squared minus 8m. And then I take 1 times all these, which is just m squared plus 2m minus 8. And I add them together to get m cubed. What's 2m squared plus m squared? 3m squared. Negative 8m and 2m. Negative 6m minus 8. So if we double distribute this one, 6n squared times n squared is 6n to the fourth. 6n squared times n is 6n to the third. 6n squared times 3n, or 3 is 18n squared. Then we take negative 7 times all those to get negative 7n squared minus 7m plus minus 21. So if we add the like terms, most of them aren't like terms. We have just one set of like terms. So it's just 6n to the fourth plus 6n to the third plus 11n squared minus 7n minus 21. There we go. Do one more of these, and then we'll get to the more advanced problems. Multiply these two together first. I usually leave my whatever's out front out front. And so then I have m squared times m is m cubed. M squared times 2 is 2m squared. Negative 1 times m is negative m minus 2. So now I have a binomial times a polynomial because we had no like terms there. So if you have no like terms, you just have no like terms. That's fine. Not the end of the world. There's just no like terms. So then we take the m times each of these. M times m cubed is m to the fourth plus 2m to the third minus m minus 2. And then take 1 times each of those. Taking 1 times each of those is m cubed plus 2m squared minus m minus 2. Then if we add them together, we get m to the fourth. 2m cubed plus 1m cubed is 3m cubed. Negative m squared plus 2m squared. 1m squared, or just m squared. Negative 2m minus m, negative 3m minus 2. All right. A box can be made out of a rectangular piece of cardboard. So imagine this is a rectangular piece of cardboard. If I cut X amount off of each corner, and it's got to be a square, not a rectangle, but a square. Now, am I doing a perfect square on each corner and making them all the same? No, I'm not, but I'm going to be close. So if I cut a square off of each corner, this is not a box, is it? But if all I have to do is fold up the sides, now all of a sudden, if I fold up the sides, I have a box. Okay? So that's how they make a box out of a piece of cardboard. Is they cut a flat sheet of cardboard, they cut certain parts off of it, and then they can fold it up and they make a box. So, if I have an X right here and an X right here, and this whole side was 19, now how long is it from here to here? 19 minus 2x. Because there's an x here and an x here. It was 19, but we subtracted off 2x. How far is it from here to here? This is 12 minus 2x. And how tall is my box if I cut x off of each corner? How tall is it? Well, when you fold up the side, if you cut x off, that's how much you're folding up. So x is your height. So your length is 19 minus 2x. Your width is 12 minus 2x. Your height is x. So then you're supposed to find your volume. Volume of a box is the length times the width times the height. So the volume equals your length, 19 minus 2x, times your width, which is 12 minus 2x, times your height, which is x. Now, normally, I would take my last two times each other, but I don't want to. I want to take these two times each other right off the bat. What's 19 times 12? 228, right? Outers is minus 38x. Inners is minus 24x. Last times last is plus 4x squared. Times another x out there. So it's 228 minus 62x plus 4x squared times x. Then I have to distribute my x all the way through there. And then I'll change the order from highest power to lowest power. So it's going to be 4x cubed minus 62x squared plus 228x. That's the volume. Okay. Surface area of a box. Surface area is the area of each rectangle you see. So we have the big rectangle. We have side 1. And then this is also side 1 because they match. Okay? And then you have side 2 and side 2 because they match. So, to find the area of the big is 19 minus 2x times 12 minus 2x. Well, didn't we already do that once? Isn't that this one right here? Okay. So then we have side 1, and there's two of them. Two side 1s. Now, side 1 is the length, which is 12 minus 2x, times the width, which is x. So it's x times 12 minus 2x. And then side 2, there's 2 of those. And so then it's x times the length, 19 minus 2x. So we just have to do the math. And there's a lot of math here. But I can copy down this one. 4x squared minus 62x plus 228. Plus, if we distribute the x squared through, it's 2 times 12x minus 2x squared plus, distribute the x through there, 19x minus 2x squared. So it's 4x squared minus 62x plus 228 plus 24x minus 4x squared plus 38x minus 4x squared. Well, this 4x squared can cancel with this 4x squared because the positive and the negative cancel. 24x and 38x add up to be 62x, so those cancel. So then you end up with 228 minus 4x squared. That's your surface area of this. Because the other parts cancel each other out. I think I did something wrong there, but I'm not sure. Something doesn't look right there. Because the no, that might be right. All right. Polynomial identities. Difference of squares. If you factor difference of squares, you get this. If you go the opposite way and go the square of a difference, if you square it, difference of squares, you factor it and you get that. Sum of a square, you write it twice and you FOIL, you get that. The square of a difference is a little different because this is the square of a sum, square of a difference. And then we have difference of cubes and sum of cubes. By the end of this, you should memorize all 5 of those. Those are factoring patterns is what we call them. Now, do you have to memorize those? No, not exactly. It would be the bottom 2 is the ones that you really want to see if you can learn. But those are the 5 factoring patterns that we'll go through. So the bottom two are the most important ones, the difference of cubes and the sum of cubes. Okay, so when we see this quantity squared, you can use the pattern. What's the pattern? Well, that's a difference of squares pattern. So if we have a minus b squared, that's the same as a squared minus 2ab plus b squared. Okay, so what would this be? Well, this would be, this is a and this is b. A squared, what's x times x? X squared minus 2 times x times 6. 2 times x times 6 is 2x times 6, or 12x. Minus 6 or plus 6 squared is 36. Boom, you're done. Now, what if you go, boy, that doesn't feel very right to do it that way? Well, if you can't do it that way, then you just write it twice and you FOIL. X times x is x squared minus 6x minus 6x plus 36. And then combine your like terms and, oh, you're there. So you got either way you can do it. Okay, I'm not forcing you to use the pattern to do it. Now, would it be nice to use a pattern? Yes, it'll help, especially in the upcoming sections. It'll help if you learn the pattern. But do you have to? No. All right. So here's A, here's B. It's a square, so it's sum of squares. So A plus B quantity squared equals a pattern, A squared plus 2AB plus B squared. Okay, from your notes. So A squared, 2x squared times 2x squared is what? 4x to the fourth power. 4x to the fourth power. Because when you square it, you're taking it times itself. Plus 2 times this times this. Well, 2 times 2 is 4. So it's 4 times x squared times y cubed, or 4x squared y cubed, plus b squared. When you square y cubed, a power to power, we multiply and get y to the 6th power. And again, if you just don't see it, write it twice and FOIL. This one is difference of squares, which is a minus b times a minus b, a plus b, which is a squared minus b squared. If they're the exact same thing with opposite signs in the middle, you just square the first one, sign them, then it's a minus sign, and square the last one. Boom. Easy peasy. Okay? If you just don't see it, FOIL it. X times x is x squared. Outers is plus 5x. Inners is minus 5x. Last times last is minus 25. Well, 5x and negative 5x cancel and be x squared minus 25. So, a squared. 3x squared times 3x squared is 9x to the fourth power. Outers and inners are going to cancel. What we call these are conjugates. These are conjugates. And then it's minus, and the last thing squared. Well, 5 times 5 is 25, and y to the 6th power. Okay? So this can really, if you know these well, it can really speed up your multiplication of these. Okay, so we'll have a worksheet. And then we'll go on to the binomial theorem.